Structures of organic molecules. Part A, alkanes. Write or draw structures of the following molecules. First, butane. Formula is C4H10. You're going to write 4 carbons in a line connected with a bond. Each carbon is bonded to the other carbon, and then you are going to distribute the 10 H's on the 4 carbons. Again, maintaining 4 bonds or 4 lines around each carbon. Condensed structure for the Lewis structure for butane would now be grouping together all the H's in each carbon. So CH3, CH2, CH2, and CH3. You don't have to write the vertical lines nor the horizontal lines on each of the carbons and the hydrogens. Line angle structure for butane would be in a zigzag pattern showing the carbon backbone. So you have 4 carbons, 1, 2, 3, 4. Isomer for butane will have the same formula as above, C4H10. So in this structure, one bond to the other carbon is placed in the middle. So this carbon in the middle will now have 3 carbons bonded to it. Condensed structure for this line angle structure would now be CH3, CH with a CH3 bonded to it, and then CH3. Lewis structure would be, for this isomer, would now be based on this structure above, in which one H is interchanged to this carbon in here, and this CH3 would now be bonded to this. You're going to draw a line from this carbon up to CH3. CH3 in the middle is now going to be bonded to the CH in here. So this is now numbered as 1, 2, 3, or 1, 2, 3, or 1, 2, 3. The second carbon contains a substituent. Longest chain is going to be a 3-carbon unit, either going this way or that way. So second carbon contains a methyl. Therefore, the name of that is going to be 2-methyl propane. Part B, alkyl halides. Draw 2 structures for C3H7Br and name the molecule. There are 3 carbons, 7 H's, and 1 Br in the molecule. So the carbons are arranged or drawn in a line, and then the 7 H's are arranged around it, and then the Br on this carbon. So again, maintaining the 4 bonds or 4 lines around each carbon. Condensed structure would be grouping together the H's on each carbon. So CH3, CH2, CH2, and a Br. Line angle structure for this molecule would be in a zigzag pattern. There's 3 carbons, 1, 2, 3, and then the parent is now going to be propane for 3 carbons. However, the numbering is 1, 2, 3. The first carbon takes the Br because that takes a lower number. So the full name is now 1-bromopropane. Another structure shown below, the Lewis structure, based on the first structure, the H and the Br are interchanged. So carbon number 2, or the middle carbon, takes the Br. Condensed structure, again, grouping together the H's on each carbon, and it's now going to be CH3, CH, and this carbon with a vertical line to Br, and then CH3. Line angle structure would now be like an inverted Y, with the middle carbon taking in the Br. So the numbering is 1, 2, 3, or 1, 2, 3. The second carbon takes the Br. So the name is going to be 2-bromopropane. Part C, cycloalkanes. Draw 5 isomeric cyclic structures for C5H10 and name the molecule. There are 5 carbons and 10 H's in the structure. The first drawing can be shaped like a pentagon. There are 5 sides and there are 5 carbons. 1, 2, 3, 4, 5. And each carbon contains 2 H's. The whole molecule contains 10 H's. There are 5 carbons, that's why it's pentane. But because it's a ring structure, a cyclic structure, the whole name is going to be cyclopentane. Next isomer would now be with a smaller ring structure. 4 carbons in the ring, like a square. But because you need another carbon, you're going to put a carbon or a methyl in either of these 4 carbons. So now the parent is cyclobutane because you have 4 carbons in the ring, and then there's a methyl. So it's called methyl cyclobutane. Next structure, you're going to shrink the size of the ring further into 3 carbons. But because you need 2 more carbons, you're going to put a carbon and another carbon in this carbon in here. So 2 methyls in 1 carbon. Therefore, the parent is cyclopropane. However, in 1 carbon, you have 2 methyls. So it's called 1, 1 for the first carbon, and then hyphen dimethyl because you have 2 methyls in the first carbon. So complete name is 1, 1 hyphen dimethyl cyclopropane. Next structure, if you put 1 methyl on the other carbon, it's now going to be the structure. So this symbol or the bond means wedge, and then it's pointing towards you. However, on the dashed wedge, it's pointing away from you. So if you put the 2 methyls on the same side, on the wedges, on these 2 carbons, it's now going to be another isomer. So on the same side, groups on the same side, they're called cis isomer. So the parent is still cyclopropane. So the complete name is now going to be cis to specify the geometry for the same side of the methyl. So complete name is cis hyphen 1, 2 hyphen dimethyl cyclopropane. So again, both wedges, the methyls on different carbons, it's now going to be same side or cis isomer. If you put this group on the opposite side, meaning on the dashed wedge, this one pointing towards you, away from you, is going to be the same name. However, the geometry or the isomer or the geometric isomer will be different. So this is now called trans for opposite side. So complete name is going to be trans hyphen 1, 2 hyphen dimethyl cyclopropane. These 2, cis and trans, are geometric isomers. However, these are structural isomers. And this structure here and this one are structural isomers. All of these will have the formula C5H10. Part D, alkenes with chlorines. Draw 3 isomers for C2H2Cl2 and name the molecule. Draw cis, trans, or geometric isomers with correct bond angles. Alkenes are structures with double bonds. So in this molecule, the formula is C2H2Cl2. You are going to connect 2 carbons together. That's going to be a double bond, and then distribute the H's and the Cl's around it. Don't connect 2 H's together and don't connect 2 Cl's together. So first structure is carbon to carbon double bond, and then the Cl's on 1 carbon, H's on 1 carbon. Line angle structure is shown in here. So the carbon is not tetrahedral, it's planar. So you can skip the carbons and then the H's, but not the Cl's. So this means carbon to carbon double bond and then 2 H's on this carbon. So the name now is, the parent is ethene because you have 2 carbons and ending with ene for an alkene. And then the first carbon contains 2 chlorines. Therefore, it's going to be 1, dichloroethene. So di meaning 2 chlorines in both carbon That's going to be connected, 2 chlorines connected in 1 carbon. That's why it's 1,1 di for 2 chlorines in 1 carbon. Next structure, you are going to put this chlorine on this side and interchange the H and the Cl. That's going to be the Lewis structure. Therefore, line angle structure is you're putting 1 Cl on this side. That creates a geometric isomer, same side, cis. So now the name is going to be cis for same side in 1, 2, because the 2 chlorines, dichloro, are located in carbon number 1 and carbon number 2. Therefore, the name is cis hyphen 1, 2 hyphen dichloroethene. That's an isomer of 1,1-dichloroethene. These 2 are geometric isomers. These 2 are structural isomers, and this and that one are structural isomers. But cis and trans are geometric isomers. So if you put this Cl on this side, that means actually you're breaking the bond and putting it on the other side. That creates opposite side. That becomes trans. So you are interchanging the Cl and the H on the trans. For the cis, you interchange this Cl to the H. So this creates now a different isomer, trans across. So the full name, again, ethene is the parent. And then 1, 2 carbons are where the 2 chlorines are. So 1, 2. However, you have to specify the geometric isomerism, which is now trans. So the full name is trans hyphen 1, 2 hyphen dichloroethene. Part E, alkenes. Draw 5 isomeric alkene structures for C5H10 and name the molecule. Include cis, trans, or geometric isomers. So alkenes have double bonds, and in this example, there are 5 carbons and 10 H's. So there's going to be 1 double bond. So first example is shown in here. The first structure, line angle structure, you will have 1 double bond. So you are going to number this as 1, 2, 3, 4, 5, or you can flip the molecule. It's going to be the same thing. So because you have 5 carbons, the parent is pentene, ene, meaning an alkene with a double bond. So 1 carbon contains an alkene or a double bond. So it's named as 1-pentene. This part here is in a zigzag pattern because this part of the molecule is tetrahedral. However, this part here is planar. So next isomer would now be shortening the length of the previous one. So this bond is going to be bonded to this carbon. That makes the longest chain only 4 carbons. So again, you have an alkene ending with ene is the name, but the longest chain is now going to be 4 carbons. That's going to be butene. So how to number this is 1, 2, 3, 4. So the parent is 1-butene, and the second carbon contains a methyl. Therefore, the name of this structure would now be 2-methyl 1-1-butene. So these 2 are isomers. Again, another isomer is based on above. Instead of the methyl bonded on this carbon, you are going to put this methyl here. So again, the same length, the same number of longest chain is 4. So the parent is 1-butene. On the first carbon, you have an alkene. But on the third carbon, you have a methyl. So therefore, it's 3-methyl-1-butene for this molecule. Next is based on the structure. Instead of the double bond on the first carbon, we put the double bond in here, which is now this. So again, zigzag. So it puts these 2 carbons, or these 2 groups actually opposite side, so that becomes trans. But the parent is an alkene again, but the second carbon contains a double bond. So you number it as 1, 2, 3, 4, 5. It's now 2-pentene as the parent. Don't number coming from this side because that gives you a high number. It's going to be 1, 2, 3. So that's not right. You number it from this side because you get the low number for the alkene. So full name is trans 2-pentene. Trans because these two groups are opposite with respect to the double bond, and then 2 because the second carbon contains the alkene. Last example is shown below. So this is flipping or changing this position of the methyl above. So you're actually breaking the bond to put it on the same side as this group in here. So you're going to rotate it slightly and then put this bond over here. That gives these two groups with respect to the double bond same side. So the same parent, 2-pentene because you number it from this side 1, 2, 3, 4, 5, and then second carbon contains the double bond. That's why it's 2-pentene. However, these two carbons are on the same side, that's why it's cis. Remember that there's an H in here, H in here, H, H. So this gives you cis 2-pentene. Part F, other functional groups. Substitute R with an ethyl or methyl group and draw the structure. First, ROH. R is any carbon chain, but we are putting either an ethyl or a methyl group. In this case, R is an ethyl. So the functional group is an alcohol. So 2 carbons in here and an OH. So the name for this is ending with OL for an alcohol, and ethanol is the final name because you have 2 carbons from ethane. But the ending is now OL, that's why it's ethanol. Line angle structure, 2 carbons, CH3, CH2, zigzag pattern because the carbons are tetrahedral in shape, and then an OH. Next functional group is R, C double bond O, R. 2 R's on both sides of the C double bond O. Functional group is a ketone, so the name is going to be ending with ONE. So the R this time is a methyl. So CH3, C double bond O, CH3. Line angle, zigzag, however, this one is planar. So you can skip the carbons and the H's, but you cannot skip the O and the double bond. So the name for this is now going to be based on 3 carbons, like propane, but the ending is ONE. So therefore, it's propanone. Next functional group is RCO, C double bond OOH, or RCO2H. So the R group is now a methyl. So CH3, C double bond OOH. Line angle, again zigzag, but this C double bond O is planar. So CH3, C double bond OOH. Functional group this time is a carboxylic acid. So the name for this molecule is based on 2 carbons, the same thing as that one. So it's ethanoic acid. From ethane, 2 carbons, but it's now ending with oic acid. So carboxylic acid will end with oic acid or OIC acid. So ethanoic acid would be the name for this molecule.